Class 11, already we have started the chapter. Trigonometric ratios are positive acute angles, and formula part and the small axioms, that is also completed. That part already completed, and few only 3 axioms are there, that is also completed. Next, I will start the exercise 2. uh, Exercise 2, this is from section 2. This are 2 marks questions. Okay, first question is, prove the following identities. That means already I have said we have to prove only LHS and RHS. Prove the following identities. Okay, first question is sine A. In my book it is 2 marks question, sum number 1, section 2. This is section 2. Section 2, question number 1, part 1. Sine A cos A into tan A plus cot A is equal to 1. That we have to prove. So obviously we'll start from the LHS. Okay. What is the question? Sine A into cos A in the bracket tan A plus cot A. Okay. As we have to prove only 1 to the right hand side, so it's better to break this tan A plus cot A, that means which is written in the bracket. This part we'll write in the form of sine and cos. Then what we will get? Sine A into cos A, and it will be sine A by cos A, plus it will be cos A by sine A. Okay, so again sine A into cos A and sine A cos A. Take the LCM and it will be sine square A plus cos square A. Okay, so this part and this part will be cancelled, and we will get only sine square A plus cos square A, which is equal to 1, which is equal to right hand side. Okay, so it is proved. Okay, next sum. Sum number 2, 1 part 2. Sin alpha, many sums are there in this chapter. Sin alpha into cos alpha into tan alpha minus cot alpha is equal to 2 sin square alpha minus 1. So LHS equals to what? Sin alpha into cos alpha tan alpha minus cot alpha. As we have to prove only 2 sin square alpha minus 1, so left hand side this part tan alpha and cot alpha. This again we have to break this in the form of sin and cos, same as before. So what we will get? Sin alpha into cos alpha, and it will be sin square alpha minus cos square alpha. First sum it was plus here, and here it is minus. Now sin alpha cos alpha, both in numerator and denominator will be cancelled, and sin square alpha minus cos square alpha. Okay, and we know as we have to prove only in terms of sin square alpha, so first term we will just keep it as it is, and cos square alpha we will write as cos square alpha is equal to 1 minus sin square alpha. Okay, so it is coming sin square alpha plus cos square alpha equals to 1, so cos square alpha will be 1 minus sin square alpha minus 1 plus sin square alpha. So it is coming 2 sin square alpha minus 1, which is equal to right hand side. So it is proved. Okay, next. part 3. One plus sine theta by 1 minus sine theta is equal to sec theta plus tan theta. Okay, so we'll start again from left hand side. 1 plus sine theta by 1 minus sine theta. Okay, as denominator is there 1 minus sine theta, so at first we will just make it we will just okay, yes, we will just rationalize the denominator. So 1 minus sine theta is there. So both numerator and denominator we will multiply by its by its conjugate term. Conjugate of 1 minus sine theta. So conjugate of 1 minus sine theta we know that is equals to 1 plus sine theta. So let us multiply by 1 plus sine theta both numerator and denominator. So when we will multiply 1 plus by 1 plus sine theta, obviously this will be 1 plus sine theta whole square. Okay, a denominator part will be 1 minus a minus b into a plus b, so it will be 1 minus sine square theta. I think now it is clear to you. 1 minus sine square theta means cos square theta, and okay, write it, and this is 1 plus sine theta whole square. As it is square and this is also square, so without square root we can write only 1 plus sine theta by cos theta. Okay, now just break it. 1 by cos theta plus sine theta by cos theta. 1 by cos theta we know that is equal to sec theta. Sine by cos we know that is equal to tan theta, which is equal to right hand side. That is also proved. Next part, sum number 5. Now, you are not in class 9 and 10 as you are in class 11. So, don't think all sums we will do in class, online class or in video. Don't think that. You have to do other sums also, that similar sums or other sums you have to try also. Okay. So, daily practice is very important, remember. Part 5. Sine to the power 4 alpha minus cos to the power 4 alpha plus 1 is equal to 2 sine square alpha. This we have to prove. Now left hand side. Sine to the power 4 alpha minus alpha plus 1. Okay. Sine to the power 4 means we can write this as sine square alpha whole square minus cos square alpha whole square plus 1. Okay. Now this again a square minus b square we will write. Then what we will get? Sine square alpha plus cos square alpha into sine square alpha minus cos square alpha plus 1. So this part is coming 1 we know, and this is sine square alpha minus cos square alpha only. Cos square alpha means 1 minus sine square alpha plus 1 minus 1 plus sine square alpha plus 1. Plus 1 minus 1 will be cancelled. Sine square alpha plus sine square alpha, that gives us only 2 sine square alpha, which is equal to right hand side. Proved. Next one, part 6. Let me rub the board first. Part 6. Cos phi by 1 plus sine phi plus 1 plus sine phi by cos phi is equal to 2 sec phi. Done. Now this is left hand side. cos phi by 1 plus sin phi plus 1 plus sin phi by cos phi is equal to. Okay, just do the LCM. Then what we will get? 1 plus sin phi into cos phi. And obviously this part will be cos square phi part, and this is 1 plus sin phi whole square. So write it directly. 1 plus sin phi whole square means sin square phi plus 2 sin phi. A plus b whole square. Now sine cos square phi plus sine square phi, this part again we will get as 1. So it is coming 1 plus 1 plus 2 sine phi. Okay. And here 1 plus sine phi into cos phi. 1 plus 1, that is coming 2. So 2 plus 2 sine phi by 1 plus sine phi into cos phi. Now take common 2, so we will get 1 plus sine phi as the numerator. Denominator already 1 plus sine phi is there. Both will be cancelled, and here it is cos phi. So it is coming 2 sec phi. I think it is clear. It is equal to right hand side. Proved. Okay. Next sums coming with new video. Thank you.